All right, so starting with example 5, we're going to solve higher degree trig equations. You see in this example, cosecant squared, right? 2 times the cosecant squared x minus 5 cosecant x plus 2 equals 0. Back above, it says that these are going to be kind of quadratic, degree 2. What we're going to do is get everything just like we would with algebraic quadratic degree 2 equations. We're going to get everything on one side and then equals 0. And then on that left-hand side, we're either going to factor or we might need to use the quadratic formula if it's not factorable. Okay? So on example 5, the first thing we're going to try to do, since it's all moved around here nice and neat, we only need to give our answers from 0 to 2 pi. That's kind of nice, okay? Now, the first thing we're going to try to do is factor the left-hand side, okay? So I think when we factor this, also known as unfoil it, if we have a 2 cosecant x here, and just a 1 cosecant x here, when we would take first times first, that would give us the 2 cosecant squared x. I like that part of it. Then we would need to find how to take outer times outer combined with inner times inner to give us the negative 5 cosecant x. And then last times last would be a positive 2. So a little trial and error here. Maybe I'm looking for what two numbers can multiply together to give me positive 2. Maybe it would be a negative and a negative to give me this negative 5, right? Okay, so maybe like a minus 1 here and a minus 2 here. Let's try that, okay? I'm going to get rid of all this yellow stuff, get it kind of out of our way. But we're going to now FOIL this out to see if we have this all correct. I'm trying to clean all this up. Move those little dots and everything. All right, get it all gathered up and then I can erase it. Okay. Now, just to check, first times first gives me the 2 cosecant squared x. Outer times outer gives me minus 4 cosecant x. Inner times inner gives me minus 1 cosecant x. Yay! And last times last, negative 1 times negative 2 gives me a positive 2. So when you combine like terms, you see we have exactly what we had on the left-hand side there. So we do have the correct factors. Now, the next step is we've got a factor times a factor equals 0. And anytime you do that, you use your zero product property to set each factor equal to 0. And we'll solve each of these equations now. Does that make sense? All right. Now, concentrating on this first equation over here, I'm going to isolate cosecant x. So my first step is to add 1 to both sides. Then divide both sides by 2. Okay? So I have cosecant of x equals 1/2. Okay? Now, if you take inverse cosecant of both sides, you're going to have x is equal to the inverse cosecant of 1/2. Now, we're looking for all the angles that have a cosecant value of 1/2. Remember, those are the same angles that would have a sine value of 1/2's reciprocal, 2 over 1. Okay? So we're looking for all the angles that have a sine value of 2. You can even punch that into your calculator if you want. Okay? There are going to be none. There are no angles that have a sine value of 2 or a cosecant value of 1/2. Okay? So there's no solution that results from this first equation. However, over here on this next equation, when we add 2 to both sides to solve for our trig expression, we will have cosecant CSC of x is equal to 2. Inverse cosecant both sides, so x is equal to all the angles that have a cosecant value of 2. Well, those are the same angles that have a sine value of 1 over 2. And I know some of those, right? We're actually going to have angles both in quadrant 1 and in quadrant 2, where sine is a positive. So, bring down the x here and here, and now we need to say, what are all the angles that have a sine value of 1/2? Well, in quadrant 1, that's going to be 30 degrees or pi over 6 radians. And, you know, you don't have to, on this one, put the plus 2 in pi, because they said you only want to give those answers in the interval from 0 to 2 pi. So I'm only going to have to say the pi over 6. And then in quadrant 2, it's that angle in quadrant 2 that has a reference angle of pi over 6. This angle in quadrant 2 is 5 pi over 6. Okay? So my final answer, okay, is just going to be the solution set that contains pi over 6 and 5 pi over 6. That is it.